Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 5th, 2025, just 4 days ago. This paper shows that redesigning rewards into utterance-level, multi-dimensional signals boosts social goal completion, hitting 7.17 on Sotopia Hard and 8.31 on the full set, beating prior reinforcement learning approaches. The paper is titled Sotopia-RL Reward Design for Social Intelligence, and the implications for model training are quite significant. In short, the method tackles partial observability and multi-objective complexity by attributing outcomes to individual utterances and combining goal, relationship, and knowledge-seeking signals, with ablations and human checks confirming stability and real gains. Building on that, tweets highlight reinforcement learning's challenge for social intelligence and introduce Sotopia-RL, sharing paper, project, and code links. Engagement looks moderate, around 60 to 70 likes each. Also, the authors shared an implementation on GitHub. You'll find a full training pipeline with scripts and configs for SFT, reward modeling, and GRPO, data processing tools, evals, and environment setup. There's a detailed README, Redis-based logging utilities, LLM deployment notes, and example configs for Accelerate and LoRa checkpoints. Alright, here the graphic showcases 4 social tasks: accommodation, persuasion, collaboration, and negotiation. Each panel gives a brief scenario, the 2 agents, goals, and a goal score summary. Building on our earlier point, the scores jump with the refined rewards, roughly 9 to 23% gains, with persuasion and negotiation seeing the largest boosts, while collaboration and accommodation also rise meaningfully. Okay, this scene illustrates a Sotopia dialogue where 2 friends play a game, each with hidden goals: stop versus keep playing. The colored bubbles show alternating utterances, while the pink boxes at the top present private goals. Building on that, the outcome bars at the bottom summarize episode-level scores. Tom succeeds, 9 of 10. Oliver fails, 1 of 10. Next, the diagram walks through the 3-stage pipeline. Stage 1 at the top shows GPT self-play generating trajectories, then an offline attributor scores utterances. Moving down, Stage 2 fine-tunes a supervised model and trains an utterance-level reward model. Finally, Stage 3 runs reinforcement learning self-play, using the reward model online for per-turn feedback, closing the loop. Now, focusing on this diagram, it visualizes the reward expansion. Starting from a single episode score, 9 of 10, the pipeline expands upward into utterance-level slots, 1 through 5, assigning each turn a contribution. Building on that, the left column shows multi-dimensional tracks: goal, relationship, and knowledge, each producing per-turn numbers that are later normalized and combined for training. Moving to the table, it compares models when paired with GPT-4o as the partner. Look at the bottom row. The QN 2.57b model with Sotopia-RL hits 8.31 on Sotopia-All Goal and 7.17 on Sotopia Hard, with the best overall scores too. Building on that, it surpasses GPT-4o used directly and beats other training methods like PPDPP, EPO, DAT, and DSI. Next, this table drills into reward designs using a behavior cloning partner. Look across the Sotopia hard columns. The direct attribution variants consistently beat uniform and scaled. The standout is the multidimensional combination, labeled Sotopia-RL, reaching 7.81 on goal and 3.80 overall, clearly higher than goal-only setups. Building on the earlier gains, this table reports human evaluations. With GPT-4o and separate human judges, the Sotopia-RL policy scores highest on goal completion, and it also shows the strongest alignment with human ratings, reflected by the top correlation value. That pattern reinforces the claim that improvements generalize beyond automated evaluators and are not reward hacking artifacts. Building on that, 2 takeaways. First, refining coarse episode scores into utterance-level, multi-dimensional rewards turns messy social dialogues into trainable signals, easing partial observability and curbing reward hacking. Second, the distilled reward model enables stable reinforcement learning, delivering higher goal completion and better interaction quality across tasks. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.